let's take you back to my 2015. So this is a year after I finished my PhD. And things started to come out, especially from social psychology, from the field of psychology. And I was very, very confused because I just spent 5 years doing a PhD and a year of postdoc to try and pursue a certain line of research. But then all these things came out, and then a big debate. Is there a replication crisis, reproducibility crisis? Do we need to pay attention to this backlash from one to another? I didn't know what was going on, but I just realized something is very important that is happening right now, and I need to act on it. And basically, a lot of people have debates on this, and I didn't like the conflict. I like to offer solutions and collaboration. So my view on this is a little bit like how people treat climate change. It's like we talk about things like green jobs, we'll see these clean water, air, and then somebody says, but what if this is all big hoax and we create a better world for nothing? This is my view of open science meta research. It's like there's all these amazing solutions that we're talking about, like preventing all kinds of questionable practices, opening up everything, leading to more collaboration. So what if this is a big hoax? There's no replication crisis? Fine, let's just create a better science, a better world for everybody. So this is my direction in 2015. I put most of my research aside and decided I'm going to pursue something different, to try something different. So I had the privilege of having 1 year of a postdoc to sit down with myself and decide what are my principles? What is it that I want to do? Should I be given an assistant professor position, a tenure track? What do I want to do with these very valuable years, the years where we need to figure things out? So I wrote down some principles for myself saying, if I am going to start a tenure track, this is what I want to do. So I wanted to try and understand what is going on for myself, not read about this from somebody else. I wanted to act together with people to really get my hands dirty in order to understand, not read a science paper from 2015 about 100 replications in psychology. I wanted to run replications myself. In addition, all kinds of challenges about meta-analysis. Are there reproducible? Are there high quality? How about the studies in them? So I wanted to do all of these things, and I wanted to be able to do this on such a large scale that I'll be able to get some meta-scientific insights in order to understand the credibility of an entire field, perhaps even for science overall. And then all these other principles of open science, things that I aspire to. I expected things to be already set when I got into the PhD, but then I realized actually science needs a lot of adjustment and fine-tuning. So I decided, okay, from all the things that I'm seeing in 2015 and 16, I'm going to pick the things that I want to try. So pre-registrations, didn't know how to do any of those. Register reports, Chris Chambers still trying to figure things out. Full transparency, how to share everything. So I just wrote down these things as principles, realizing that these are the things that I want to do my postdoc and my first years as a tenure track. And finally, the grand principles of tying everything together. So I want to do open science, I want to do meta science, and I don't want to do this alone. I want to have a community where I collaborate with other people in order to promote this even further. So these are kind of like the building blocks of what I want my academic career to look like. So I was trying to figure out how to do this. So things started to happen. Back then, 2017-18, Psychological Science Accelerator. So in psychology, we decided we're going to run many labs. So at the beginning, it was many labs, 1 and 2 and 5 and 4, and then started to come out where we get lots of labs of psychology in different parts of the world to collaborate together. So we have the Psychological Science Accelerator, and I participate in those. And every year there's 3 or 4 of these projects that come out. During the COVID pandemic, we had a few things that tested interventions in different parts of the world in order to see the aggregation of those and cross-cultural differences, but also testing meta-scientific insights in order to see what is more replicable. Does it help if we collaborate with original authors or not? Can we draw anything about the process of science from that? In addition, FORT is a very interesting collaboration, mainly from early career researchers, so very grassroots, in order to build an educational foundation on how to teach meta science and open science. And finally, I decided all these are great, but I want to have something that I built for my own in order to address the things that I care about. And this is where I started to think about to open this one. So I presented this in 2022 after already 4 years of building this at the University of Coimbra. So I'm going to share a lot from this collaboration. The model that I had in mind is I want to figure things out for myself. I don't want to stand in front of a classroom and preach this to other people, saying, I know the truth, this is my truth, follow me. I want to figure this out with others. So I said, I'm not going to teach any of the courses with the traditional books. I'm going to set all these books aside, and I'm going to invite students on a journey, a flipped classroom. So I did my postdoc in Maastricht University, where they have problem-based learning. And I decided the problem that I'm going to present to students is this replicable? Is this reproducible? Is this credible or not? And we'll figure this out together. So I don't know if these findings in social psychology, are they true or not true decision-making, but I want the students to come and figure this out with me. So we decided we're going to do best practices, checks and balances, and we're going to work with the community. And we're going to try and do this on such a large scale in order to be able to have some meta-scientific insights by doing systematic mapping of a lot of findings in decision-making and social psychology. So this was very ambitious back in 2018, just joining University of Hong Kong. I had a lot of resistance, and people were just like trying to figure out, what is it that you're trying to do? You're running replications with who? Undergraduate students in courses at University of Hong Kong. You're not teaching the book. You're actually inviting them to do replications. A lot of confusion, and typically, especially at University of Hong Kong, they're not used to this kind of engagement. They're not used to problem-based learning. So I had like 2 years of just trying to figure things out, just to set everything up so that we can embark on this. I just want to say that after 6 years, I consider this to be a very successful proof of concept. So it started from all these students that took part in my courses. So we're talking about 390 students that went through my courses, and all of them conducted replications and extensions, research assessments. They got their hands dirty into trying to do science projects that at the end would be publishable. I involved all of my thesis students, about 445 throughout the 6 years. And in addition, and this is the important part about the community, is that we started this in my courses at the University of Hong Kong, but once we finished, we invited the entire academic community in order to join us. So I would go on Twitter, X, Blue Sky, LinkedIn, Facebook, and all that, and I just say to others, this is what my students did at the University of Hong Kong. Who wants to join us? And to my great surprise, a lot of early career researchers said, we want to. And then we started collaborating with them. So 2017, joining University of Hong Kong, I said, I want to do an integration of research, education, and community, bringing them together in order to embark on this core team. So we have a few components. I'm going to touch very briefly on each one of them and give you a few examples and just give you a taste of what's happening. But I'm going to go through these. We have a lot of systematic verifications and extensions and a little bit about meta-analysis. We, through the process, build a lot of community resources. So I realized that if I'm going to be the only one who tells the students, okay, here's 2 pages I wrote about how to do replications, we're not going to get anywhere. So everything that I did was always on a Google Doc, saying to students, first try to figure this out for yourself and add to this. If you don't know the answer, write a question. And me and my teaching assistants, instead of replying just to that student email, we would put this on the Google Doc. And then we would go on Twitter, X, and Blue Sky and say, here is what we're doing. Do you want to improve this further? And then suddenly people from all over the world contributed to more of this. So we have a lot of templates, guides, books, ways to help people, first us, and then the entire community, to do all the things that we do. Then we have science assessments. So how do we know whether something is credible or not? Not just of others' work, but also on our work. So testing this on ourselves and then sharing this with others in the community. And then finally, the grand aim of this is, after we have so many of these, to be able to draw some meta-scientific insights in order to inform science on what we can do in order to improve more. After 6 years, how many have we done? We've done a lot. So I did this for the first 4 years of my tenure track. So 150 classic effects. We've done replications and extensions, and this involves more than 80 pre-registered replications and extensions. We have a lot of registered reports, so this is a very promising future direction for the future of science, I believe. To gain some meta-scientific insights, we ran prediction markets with economists in Sweden and around the world, and also prediction polls, and I'll share a little bit of that with you, a lot of collaborative guides, and a lot of research assessments. So after all this time, now I can say that we have some kind of an impact. We were talking about this before. It's like the first 2 years, people are coming to me and saying, what are you doing? You're supposed to publish in all these high impact factor journals. You need to have a lot of publications. What are you doing for the first 2 years? And I said, please hold on, just give me 2 years in order to try and get this core research core team running. And only in 2019, we got the first publications out. So it took us 2 years. And then now we can see that there's this real growth in the impact and the number of publications that are coming out and the impact that this is having on the community. And all this, I remind you, are early career researchers and students at University of Hong Kong with this collaboration, an international collaboration team. So I'm very glad to see that after all this time, this has worked out. But at the beginning, this was a big gamble for me. So I wasn't sure this is going to work out. It's very, very small, so I'm not going to like trouble this, but I just want to show you the first year where things really started to come up, this is 2021, suddenly we had a lot of publications come out. I just want to show you the model. The reason why this is here is I want to show you that all these underlying names, all these are Cantonese Mandarin names, University of Hong Kong, all these are undergraduate students. So the things that I was hoping that they'll do in one semester ended up being publishable. And if you look at the list afterwards, you'll see we were able to get replications into some of the very reputable journals in psychology. And now it seems to be taken for granted, okay, you can publish replications in psychology. Back then in 2019, 2020, This was a big gamble, and I wasn't sure this is going to pay off, but we've got the underlying, these are the students. We've got the early career researchers that I told you that joined us from around the world that I included with Twitter. They are the first authors, so all of them are shared first author in a note, followed by the teaching assistant. So anybody who contributes gets credit. And then finally at the end, we challenge. So it was nice to see. Until 2021, I wasn't sure this is going to work on. So I just want to show you this in order to tell you that this is a successful proof of concept that we can involve people, students, as early as second year undergrad. So these are 19-year-old students in the University of Hong Kong to result in one semester in publishable, high-quality open science and meta research. So 6 years ago, I wasn't sure this is going to work out, but now I can tell you with confidence that this is definitely working, and the impact that this is having, both on the students and my department and my university, and broader when I get some feedback from the community, it's been very impactful, and the feedback has been very, very positive. But none of this would have been possible if we didn't have the support of the community and all these early career researchers from around the world working with us and being very enthusiastic about this. So I'm going to share just very briefly some of these with you. I won't go into a lot of detail, so just to give you a taste. So meta-scientific results. So you ran so many of those. We concluded over 150. We're still trying to code these. So these are very complicated replications of many studies within a lot of articles. But I can give you just like a general sense of where we are with this. So in social psychology, if we aggregate everything on a meta-scientific level, I would say that generally, right now, the replication rate is somewhere between 30 and 50%. And the effect size seems to be about half of what was published originally. I chose to do all these mass replications on judgment and decision-making. I'll give you an example of why I chose this domain. And I can generally say it's very surprising that this is a success rate of about 68%. So the first thing you can take from this is not everything is broken. Actually, 68 is pretty good, especially when you compare this to some of the other things. And I think the reason for that is, first of all, this is a non-random sample, so I chose these studies. These are classic effects from judgment and decision-making dating back all the way to the 1970s. But beyond the success rate of judgment decision-making, which is very simple, usually there's a vignette, very simple manipulation, and stuff that we can collect data on online samples. But I want you to consider about this is that at the beginning when we started with undergraduate students at University of Hong Kong, I reached out to original authors and I said, we're going to run a replication of your studies. They said, who are you? A first-year assistant professor, students at University of Hong Kong, halfway around. There's no way this is going to work. So already I can show you that this successful proof of concept is also not just about judgment decision-making, it's also about us being able to reach this success rate. But it's not only in the success rate, this is kind of like outcome bias, but also in the mixed and inconclusive, we were able to draw conclusions about what worked and what didn't work and why. And even in the unsuccessful ones, we were able to identify some reasons for how we can improve those and whether something should be just tossed aside or whether we can refine this and do something a little bit more than that. So I'm just going to give you an example of two replications that we've done. One is about hindsight and outcome biases. These are very prominent in decision-making, but I think also people who come from medicine realize this, that when you know the outcome, this affects the way that you evaluate the process all the way out to the outcome. And I feel like this informs not only medicine, not only psychology, but this informs the scientific process overall, because when we submit to the journals, we submit this with everything. We submit this together with the results. And the reviewers, as much as they would like to be unbiased, they see the results, and then, whether they want it or not, subconsciously also reprocess what it is that they think about the article, the process that was done. So there's these two very prominent findings in 1975 and 1980s about hindsight bias. So people are not, whatever the result is, people are not surprised by this. It's a positive, negative, p-value above 0.05 or less. People are just not surprised by this. So whatever you tell them, it's like, oh, there's no value in this. It's not surprising. Second thing is outcome bias, and this was shown on medicine, so medical decision-making, is that same kind of decision, if it led to the patient being the patient dies or the patient was completely recovered, this already informs people back calculate what it is that they thought about the decision, and this informs it. So we successfully replicated both of these studies. I just want to show you that we extended this. So not only are we running replications, but these students, these undergraduate students, these early career researchers also add extensions. So we try to take the original paradigm and then we add something on top of this. So this is the publication. You can see the model, the early career researcher at the start, and then the students, and then the teaching assistant, and then myself. And then we add another study. And here, the study number 3 is that we were really worried because we kept submitting replications to journals, and the journals say, okay, but this is not surprising. How come it's not surprising? Because if it's a successful replication, of course it's a successful replication. It was already published in a top journal, therefore not surprising. If it's a failed replication, somehow they come up with all kinds of reasons for why this is not surprising. So we actually ran another study where we tested hindsight bias, outcome bias regarding the replicability of outcome bias and hindsight bias articles. And we were able to show that people, and this is how we got this into that journal, we were able to show reviewers that actually in advance, for them to say that this is not surprising after seeing the outcome, is because of hindsight bias and outcome bias. You can see a little bit of the numbers here. So foresight, there's no outcome whatsoever. People estimate the replicability to be 65, so people are a little bit optimistic. If we tell them that this was a successful replication, what would you predict that the success rate would be? People adjust this to 73. If you tell them this was a failed outcome, failed replication, they adjust this down to 52. So once we're able to demonstrate hindsight bias, outcome bias to reviewers regarding the replicability of hindsight bias, then it's easier to use this. And now every time we submit a replication, we say, okay, hold on, be careful, outcome bias, hindsight bias. The solution to this, if we understand that there's outcome bias, hindsight bias, we've known this since the 1970s and the 1980s. Have we done anything about this in science? We really haven't, because we still submit everything together with the outcome. So the model that I think is the relevant one is registry reports, and we need to head in that direction. So the new goal for the core team since 2022 is to do all of the confirmatory quantitative research as registry reports. It has this two-stage model, where the first stage is done on a pre-registration with no outcomes whatsoever. And only once everybody agrees on the pre-registration plan, only then we get an in-principle acceptance, and then we move on. So there is a reason for why registry reports are needed: outcome bias, hindsight bias, publication bias, confirmation bias. There is a way, there is a solution, and we try to implement this as much as possible in 14. The second thing I want to share with you is the belief in the law of small numbers. So this is the first study that Kahneman and Tversky ever did. People don't know this, but judgment decision-making started from them going with this kind of paradigm, saying, okay, so this is the statistic, and now if we run a replication, what is going to be the result? So they went to statistician conferences, mathematical psychology, and they gave this, and they said, what do you think the answer to this is? And they've shown, and this is this paper, it's been cited many, many times, and this is one of the things that led to the Nobel Prize. The only psychologist to ever win the Nobel Prize, Kahneman, is that they went to the mathematical psychology and the American Psychological Association, and they showed that even statisticians, even psychologists, even scientists have this problem in the belief in the law of small numbers. It means that even based on a sample of 20, people predict very high replicability. This is, of course, unwarranted, unjustified. I just want to say, we ran this as a registry report. 50 years later, we ran this again. I ran this with a thesis student in undergraduate, and we ran this. We got an in-principle acceptance from the peer community in registry reports, so I'm going to talk a little bit about that. We were able to very successfully replicate this also with a layperson sample. So we show that people have a real bias. So what does it look like? You can see over here, this plot, you can see the results. So people are fairly optimistic about things. So somewhere around 60, they said the chances of this being replicated is 60. We also ran an extension. So I'm going to give you an example for what an extension looks like. So we said 20, so the original problem had 20 sample, and then we said, how about times 10? So a sample of 200, a sample of 2,000. Does this change your estimate of replicability? And it looks like people don't change their estimation of the probability of replication. So the one from 20, a sample of 20, is about 58%. They adjust this slightly, times 10, 70%, times 100, it's about the same, only 70%. So first we had a paradigm from 50 years ago, the first Kahneman, Tversky decision-making, and then we added some extensions in order to see whether we can draw some conclusions about the way that people look at power, the way that people look at replicability. So we've known about this since the 1970s. Did we overcome this? And one of the ironies and one of the reasons why I like sharing this case study is that we really didn't. And what ended up happening is that Daniel Kahneman, the one that warned the world about this in the 1970s, fell into this trap himself. So he came out with Thinking Fast and Slow after the Nobel Prize. And in this book, there is a chapter about what we call social priming. And he called the reason, the summary that he gave for social priming is that the results are not made up, nor are they statistical flukes. But the thing about social priming is that most of the samples are based on 20 participants, 30 participants. So Daniel Kahneman was one of the people who warned the world about the problem about very small samples and problem of power. But when he summarized this in his book, he failed to internalize this message. And I'm not saying this, he is saying this. He went to a blog and wrote about the irony of this whole thing. There's a special irony in my mistake because the first paper that Amos Tversky and I published was about belief in the law of small numbers, which allows researchers to trust the results of underpowered studies with unreasonable small sample. Our article was written in 1970s, but I failed to internalize its message. The reason why this is an important case study and why I train my students based on this, because if the person who warned the world about this in the 1970s fell into this trap, then any of us can. And this is the link that I have to decision-making. Why did I want to do decision-making? Because I feel like the problem that we have in science are very much about us, humans, being fallible. Even people like Daniel Kahneman fall into this trap. Finally, meta-science. We have meta-science here on the side. We do a lot of things. I'm going to touch on this very briefly. Prediction markets. So we ran this. We can see that generally people have some kind of intuition. So the correlations between what people predicted and what actually ends up happening is 0.43. This is one of many projects that are ongoing. So Anna Drever and the Stockholm team has been publishing a lot of those, and these are generally in line with those. So even judgment and decision making, it seems like people have some kind of intuition, but the correlation is not 100. So testing this against AI and against many other things, but this is one of the things that we can do once we have 150 of these replications. So here we only did this for 28. Now we're quoting all of the others and we're running all of the other things. I also run these things on Twitter. So if you follow me on Twitter X, then you might have seen this. Every time I have another batch of replications, I do another one of those. I started in 2018, 19, 2020, 20, all the way to 2024. And then I can correlate them to see whether people can predict the replicability or not. And what are the factors that can influence the predictability on how good this is or not. We also try to code a lot of the insights that we have. So we have not only 150 of these classic articles, but we also have a lot of other things about the scientific process. So we submitted this to a lot of journals. So we have a lot of decision letters. We have hundreds of decision letters, both rejections and acceptances. So it allows us to do all kinds of meta science coding. I joined Fort, so they built this beautiful platform. You can see one of the outputs. So our team is helping Fort to code some of the things. So you can see some of the Shiny apps, and if you want, you can only look at the core team in order to see of all of these applications. What are the insights? How do they differ between the different psychology domains and so forth? But I think this is something that's needed. So we're talking about widgets and apps and Shiny apps and all this. We now have an enthusiastic team in Fort, early researchers from around the world working on solutions like that in order to inform science and to be able to draw some meta-scientific insights. Meta-analysis, I'm just going to go through this very, very quickly. We know about all kinds of problems from this team as well. So lots of issues with meta-analysis, lots of issues about how to improve meta-analysis. I just want to say we do all kinds of things like including a form, how to do pre-registration on systematic review. So now if you go to the Open Science Framework, there's a way for you to do a registration that has all these. So there are solutions that the team is coming together through a conference called SIPS, the Society for Improvement in Psychological Science, all of us together, early researchers, students, journal editors, sitting together in order to address and come with solutions. In addition, the team that I'm working with has templates for how to do a registered report of meta-analysis. So if you're doing a meta-analysis, I invite you to go. We have one for correlational, we have one for experimental, we have a coding sheet for you, we have the R markdown ready for you. We have a template for how to write a manuscript that is fully reproducible and open science of the highest quality. So please do go and use that, and if you need any help with this, we're available too. In addition, a big collaboration of people who are experts about meta-analysis, so how to help others do a higher quality meta-analysis. It's not simple. The first thing that you need is a good syllabus. So an aggregation, there's like 50 pages of links over there trying to help people to find the information needed in order to do meta-analysis in a reproducible and open way. So use the meta-analysis syllabus, please. Community resources, we have a lot. I'm not going to touch too much on this. We have over 25 of these things. I'm going to just mention two of them. One is a very big journal, very impactful, reputable psychological bulletin in psychology. So the editor is here, the reproducibility team is here. So all these experts together come in order to do the guide to how to calculate effect sizes and confidence intervals, which is highly needed. I didn't realize the complexity about 6 years ago, but now I do understand, and it's thanks to these experts coming together in order to have this resource. And the way that I do things with students is that I give them a template, and the template is what makes things possible. So the success is very much because we have very good templates. I did not build this by myself. It's a collaboration of a lot of things, but we do have a template for how to do an empirical register report. Science assessments, also very briefly, but we started to do science assessments. So how do we know whether something is credible, reproducible, replicable? So each year I was training students in order to try and do some assessments of science. Now we have a very good template for this. At the beginning, we started to do this for the big many labs and the open science collaboration. But then people said, you're looking at other people. How about yourself? Did you test yourself? And then I said, yeah, you're right. I'm going to test this myself. So every year from 2020, 2021, 2023, students always look at the replications that we did the year previous to that. So we have a lot of checks and balances. Not only are we doing preprints and then inviting early career researchers and then going to Twitter and then putting everything in the open science framework, but every year, the year after, we have students doing assessments of what it is that we did in replications and extension, and it really seems to be working. So for example, retraction watch, some of the students found some of the mistakes. It starts from something as simple as doing a stat check, but sometimes it goes into something more elaborate. So you can train undergraduates in order to look at a paper and see whether something is credible or not. So it's nice that this led to an expression of concern, and then realized that the editor of psychological science, in this case, realized that they need to do something in order to revamp their editorials. In addition, I have a pledge. I really hope that this pledge will become mainstream. My pledge is check me, replicate me. I don't know why in science we don't invite more people in order to check us, help us to find errors. I don't want in 20 years somebody to find an error that I could have found much earlier and wasted billions of dollars and a lot of people involved. So I have this pledge, I pay money. So I invite you to come in and earn money by finding my mistakes, and I will pay you for every minor mistake. I will pay you $5 for every major mistake, $50 US. And I also offer this to my students. So besides the grade that they get if they find a mistake, they get money, and they did find mistakes, which is really, really nice. But then I offer them the option of you can either get this money, you can get cash, or if you decide to donate this, so effective altruism, give well, effective charities, then I will match it. And all of them have decided so far to donate this to charities. So win-win for everybody. Win for the students, they learn something. Win for the charities, they get something in order to help the world and improve the world. Win for me, because these are embarrassing mistakes that were caught before this was published. So we can have more people take this kind of pledge. We can find systematic ways of funding this kind of way in order to pay people who devote their time in order to find mistakes. And there's lots of solutions. I'm going to end with this of how do we make this more mainstream? What is the one solution that can really help revamp things in the fastest way? I believe in this pyramid by Chris Chambers. Right now, status quo research should not inform policy. We should be very, very careful, humble, cautious before we alert the media. But we found the COVID vaccine or our COVID treatment. We need to be very, very careful before we have something a little bit open science. So if we share the data materials, it gets us a little bit closer to the green. If we do conformatory, so we have a pre-registration, then it gets us a little bit closer. But the highest standard, I feel, is register reports where we overcome publication outcome bias, Hindsight bias, confirmation bias. And then finally, if we have a meta-analysis of register reports, then this gets us as close as possible to what I would consider to be high quality research that should really inform policy. If you want to know more about this, Chris Chambers does a much better job than I do. I just want to tell you that we wanted to set an example. So I decided that everything that I do with my thesis students is going to be done as register reports. Not only this, but I met Chris Chambers and I asked him in 2019, I asked him, how do I do a register report in a way that would allow a one-year thesis student to complete a register report? And he said, wait, peer community and register report is coming in 2021. It will solve this problem. And it really did. They really lived up to the expectations. And once they came up with this, I just changed everything that I'm doing in order to address peer community and register reports, what we call register reports 2.0. I just want to touch very briefly on some of the benefits. The biggest benefit that I had is that they offer scheduled reviews, which means guaranteed peer review within 2 weeks. This means that for the first time I could schedule the thesis, undergraduate thesis, within 6-8 months in order to complete a register report. So one of the complaints about register reports is that it takes too long. It really doesn't. My students do this within 8 months. Open peer review, identified, and you don't need to commit to a journal. We can talk a lot about that if you want to know about peer community. But I just want to say that I've been able to successfully show proof of concept that all of my undergraduate and master's thesis students were able to go through the peer community. We've had 0 rejections so far, and all of them have received in-principle acceptance. This is what it looks like. So you can see the recommendation. In this case, Chris Chambers was the one to review things. And then finally, once it was endorsed by peer community and register reports, it was automatically endorsed with no additional peer review in Collabra Psychology. So there's no conflict between peer community and publishing in traditional journals like Collabra. And as you can see here, the nice thing about this peer community and machine reports is that everything is open. You can see our first submission, you see the second submission and how we replied, all the feedback that we received, and the way that we replied to it. You can see the simulated data in the code, and then you can see the data in the code afterwards with the raw data sets. So everything is full transparency in the peer community. So students really learn hands-on how to meet the highest expectations of open science. We've done a lot of those. So these are the publications, and then there's more in principle acceptance. Just want to say it's possible. If you want to go in this path, it's possible to do this with undergraduates as early as second undergraduate. To summarize all this together, I know that this was very, very fast, but we can talk about any of this more in detail. I also have a lot of talks that you can follow up on this. But finally, at the end, we have these two things that are complementary. So we want to aim at collaborative open science meta research, and we do all these things with the community and early career researchers and students in my team. So systematic replications and extensions, meta-analysis, science assessments, resources for the community, and then finally meta scientific insights. So all this, after 6 years, is a very successful proof of concept that not only can we learn about what's happening with science, not only can we tell others, you should do this, but we can also set an example. We should provide a proof of concept to show them, we've done this. It's easier than you think. Just follow the path that we laid in order for you to be able to do exactly the same. And if you need any support, we're here to support you with all the resources, all the templates, all the guides, all the videos that you might need. So everything that I talked about is on my website. If you need any information, just go on this link, the barcode, and this link. I'm also very active on, used to be Twitter X, now more of a Blue Sky community. We have a mailing list every 2-3 months. Something else comes out that summarizes everything that we've done in the core team, and a lot of talks, not just by myself, but also from the others in the core team. Thank you very much.